Hello student, today I will define you the gradient of a scalar function. Okay. So we know we are discussing about the multivariable calculus. So the function is f is some function of f x y z. Okay, and the gradient function, gradient delta, is defined by, this is just like operator, so I del over del x plus j cap and del over del y plus k cap del over del z. So the gradient is defined by delta f, which can be written as I delta f over del x plus j del f over del y plus k del f over del z. So this delta f is the vector function. Okay, so the gradient is the vector function and it has some properties. So the properties of gradient. Okay, so the first property, if your f is constant vector. Okay, so sorry, the constant function. Okay, so if f is constant, just say it is c. It is c. Okay, so then delta f will be 0 because you know the derivative of the constant is always 0. Okay. And secondly, the scalar multiplication property. So delta times of alpha times of f. So alpha is the scalar. Okay, so you can put alpha in the alpha before this delta. Okay, so this alpha times of delta f. So this shows that the del operator is the linear operator. Okay, and thirdly, the additive property, or you can combine the additive and scalar property, alpha f plus beta g. Okay, so you can write like alpha times delta f plus beta times of delta g. So this is the pure linear property for this operator. Okay, so by using these, we can have the product rule as well, but let's discuss in the example. Okay, so example f is exponential x y z. Okay, so you need to find this delta f, one thing, and secondly you need to find delta f at 0 0 0. That means after finding this delta f, we need to put x equal to 0, y equal to 0, z equal to 0. Okay, so let us see the partial derivative fx. So fx is what? You know the differentiation with respect to x, that means y and z will be constant. So the partial derivative is e over xyz. Okay, and yz will be before. So the yz e to the power xyz. In the similar way, f of y is xz exponential xyz. Okay, and finally the third thing, fz. So the partial derivative with respect to z, it is xy exponential xyz. Okay, so these are the partial derivatives, and by using a definition of the delta f, the gradient f is I times fx. We can write in this way as well. Okay, and g cap times fy plus k cap times fz. Okay, so let us put the value of fx and fy from the vector function. So you know the exponential function is common from the all, so we can write directly xyz in the bracket yz I cap plus xz j cap plus plus xy, okay, k cap. So this is the gradient function for the value for the variable in the variable form, okay. So in the second part of the question we have to put the value of x, y, z as 0. So by putting x equal to 0, y equal to 0 and z equal to 0, okay. So x, y, z equal to 0, then this delta f 0, 0, 0 equal to you know that when you put x, y, z, so all these things will be 0. That means this is 0 I plus 0 j plus 0 k, okay. So by the similar way we can find the delta, the gradient function, the gradient vector at some other point as well, okay. So let us give some more example for this. Let us say the point P is vector, uh, the point is 1 0 0, okay. So when we put x equal to 1, y equal to 0, z equal to 0, then delta f, this gradient f is 1 0 0 equal to what? You can see in the vector function, variable vector function. So y and z are 0. So you can see that again all things will be 0 because you have only one position is non-zero. So this is also 0 I plus 0 j plus 0 k. One more thing, let us take another point P is let us say 1 1 1, okay. So this is 1 1 0. That means you have to put x equal to 1, y equal to 1 and z equal to 0. So the gradient f at this point is 1 1 0 equal to, so here you need to put x equal to 1, y equal to 1 and z equal to 0. So the exponential power will be 0, okay. And in the bracket whenever we have a product of x, y, that is only non-zero and the rest of the 0. That means this is 0 I, okay, and 0 j plus k. So what is our answer? Answer is only the unit vector k, okay, and the rest of them is 0. Thank you.